Drop a heavy Olympic plate onto a textured rubber surface, and the kinetic energy forces an immediate, violent compression of the flooring material. That massive mechanical stress is compounded daily by a heavy chemical and biological load. Sweat pools heavily around free weight zones, microscopic skin cells settle deep into the texture, and spilled pre-workout formulas introduce reactive compounds directly to the surface. Add to this the constant high-friction grinding of hundreds of rubber-soled athletic shoes, twisting and pivoting under heavy loads. This damage profile applies differently across the diverse architectural zones of a single facility, from vulcanized interlocking mats and sprung timber courts to vinyl sports surfaces and polished concrete. The environmental stress inside a fitness center vastly exceeds that of a standard commercial office or retail space. Applying standard office cleaning methods to this environment guarantees rapid destruction of the asset. Many facility managers assume that aggressive alkaline degreasers paired with high-temperature water are the ultimate tools for maintaining heavily used commercial spaces. But treating a gym floor like a standard janitorial task ignores the physical properties of the materials involved. This is strictly an exercise in applied material science. Applying the wrong chemical pH to a highly specialized surface breaks down its structural integrity at a molecular level. Once that integrity is compromised, the consequences cascade rapidly. The floor develops severe slip hazards, manufacturer warranties are invalidated, and operators face capital replacement costs running into the tens of thousands of dollars. Maintaining a legally compliant and financially viable gym requires precise chemical matching and rigorous empirical testing to navigate the specific vulnerabilities of each material. Most heavy lifting zones rely on interlocking tiles or rolled sheets manufactured from recycled styrene butadiene rubber. This structural model shows styrene butadiene polymer chains bound tightly by sulfur crosslinks, giving the rubber its elasticity. Chemically, maintenance must be restricted to pH-neutral detergents operating exclusively within a 6.5 to 7.5 range. Eliminating aggressive pH swings from the maintenance schedule is the only way to preserve the rubber's elasticity throughout its intended lifespan. Preserving the material naturally leads to preserving the safety of the members. Workplace health and safety compliance is a legally binding duty of care for operators, and slip resistance is the primary liability. You cannot assess the physical grip of a floor by looking at it or touching it. True slip resistance requires empirical measurement. This schematic illustrates a wet pendulum test. To be legally safe, gym surfaces must achieve a minimum P4 classification, a value above 54. But pine oil cleaners leave a waxy lipid layer, instantly dropping the safe 62 reading down to a dangerous 41. Relying on unverified off-the-shelf cleaning products transforms a chemically sound floor into an active legal liability. Group fitness studios and basketball courts constructed from Australian hardwoods like spotted gum introduce an entirely different set of physical vulnerabilities. The raw wood is never meant to be exposed to traffic. The floor's durability relies entirely on a micro-thin, protective polyurethane seal. Look at this timber cross-section. Steam mops force intense heat and vapor pressure straight through the polyurethane layer into the wood grain. The cellular structure swells irreversibly, forcing the boards to warp upward and permanently break the surface tension. Timber requires a strict low-moisture protocol. Microfiber flat mop systems use 90% less water than string mops, relying instead on fast-evaporating, sport-specific cleaning solutions. The threat of moisture extends beyond the mop bucket. Ambient humidity, particularly in coastal climates, acts as a constant invisible pressure on the timber. Facility HVAC systems must be engineered to maintain interior relative humidity strictly between 40 and 55% year-round to prevent the boards from shifting. For timber sport surfaces, water does not clean. It acts as a structural wedge that routinely causes five-figure repair bills when left uncontrolled. Beyond physical wear and chemical damage, gym floors serve as active biological incubators. Bare feet, pooling sweat, and high ambient heat create ideal conditions for cellular growth. Routine swab audits of these surfaces identify heavy microbial loads, including Staphylococcus aureus, methicillin-resistant Staphylococcus aureus, and Trichophyton rubrum, the fungus responsible for athlete's foot. Eradicating these pathogens require hospital-grade quaternary ammonium compounds, strictly diluted to 800 parts per million. But chemistry alone is insufficient. These disinfectants require an undisturbed 10-minute wet contact time to achieve their kill rate. Mopping the solution dry immediately after application renders it completely useless. Scent and visual clarity offers zero proof of biological cleanliness. A surface can look entirely spotless while harboring a dense microbial load. This ATP relative light unit gauge quantifies cellular matter on a surface. A reading below 100 RLU is biologically safe, while anything over 250 RLU is a definitive failure, instantly triggering a mandatory reclean protocol. Without precise chemical contact time and empirical ATP verification, a floor is never actually disinfected. It is merely wet. The most effective strategy for managing floor degradation is to intercept the soil before it enters the building. Proactive facility engineering vastly outperforms reactive cleaning. This schematic maps out a highly engineered 3-stage entrance matting system, dividing the threshold into distinct capture zones. First, an exterior coarse square scraper acts as the primary physical defense, stripping heavy aggregate and street grit directly from shoe treads. Next, a vestibule medium bristle brush mat aggressively captures the medium grit particulates that survive the initial scrape. Finally, an interior fine microfiber mat serves as the finishing stage, absorbing residual moisture and trapping microscopic dust. Implementing this exact sequence yields a measured 68% reduction in abrasive soil reaching the specialized gym flooring inside. Reducing the volume of incoming soil directly extends the required intervals between intensive deep cleans, preserving the floor's wear layer over a much longer timeline. Executing predictive, material-specific maintenance protocols demands a high baseline of technical training and specialized equipment from the service provider. Opting for cheaper, reactive cleaning strategies to save on daily operating expenses guarantees premature asset failure. This graph projects capital expenditure over a 5-year timeline. The line representing reactive janitorial methods spikes drastically at year 3 due to catastrophic replacement costs. The material science protocol line remains low and stable, creating a massive 50% reduction in total spend. Protecting polymer crosslinks, strictly enforcing moisture thresholds, and demanding ATP verification testing are direct mechanisms for protecting a facility's bottom line. In high-performance commercial spaces, floor compliance is never an aesthetic exercise. It is a rigorous discipline of